Hello, welcome back. Today we're going to be talking about graphing quadratics using transformations. Now this is the second part of the video, and by the end of this video you should be able to graph quadratic equations again using transformations. So without a graphing calculator, we're going to graph y equals 3x squared minus 4 using transformations. Our first step is we're going to go ahead and write down the transformations of the equation we're given. Now that's an abbreviated way of saying we're going to compare the graph of y equals 3x squared minus 4 to the parent quadratic function of y equals x squared. We did that in the previous video, part 1. So the transformations that are represented by this function are, notice you have a 3 times the x squared. That means we're going to vertically stretch our graph by a factor of after we shift it by, or stretch it by a factor of 3, then we're going to go ahead and shift our graph down 4 units. That's what the minus 4 does. So we're going to shift down 4 units. So I went ahead and gave us an XY chart, provided that for us here, because the next step is to graph the quadratic parent function, y equals x squared. We usually pick an x value of 0 and a couple before 0 and a couple after 0. Then we take negative 2 and we square it. So negative 2 squared. We take negative 1 and square it. 0 squared, 1 squared, and 2 squared. And the reason, again, we're squaring these values is because our y's are equal to all of our x's squared. So we take negative 2, which is our x value, and square it, we get 4 for y. Negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Then we're going to plot these points on our x, y coordinate system. So we take negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. Now our first step, again, is from our transformations. We're going to vertically stretch all of those points by a factor of 3. So what that means is we take the height, or the y values, and we multiply them by 3. So our y value for negative 2 was 4. We multiply that by 3 and we get 12. So 10, 11, 12. 1 times 3 is 3. 0 times 3 is 0. 1 times 3 is 3. And 4 times 3 is 12. Then we're going to take those points, and for our last transformation, we're going to shift them down 4 units. So 12, we're going to shift down 4. So it becomes 12, 11, 10, 9, 8. 12, 11, 10, 9, 8. And then we take our 3 right here, the red, and we shift it down 4 units. So 3, 2, 1, 0, negative 1. The 0 shifts down to negative 4. The 3 shifts down to negative 1. And in the green, we have the final location of our points. They have been shifted, rather they've been stretched by a factor of 3 and then shifted down 3 units. So I'm going to go ahead and graph another example for you. This one is negative 1/2 x squared plus 1. So again, we're going to follow through our steps. First thing we're going to do is list our transformations. So notice you have a negative 1/2. First I'm going to take care of the 1/2. Remember, we always go in PEMDAS order. So the 1/2 means we're going to vertically shrink all of our points by a factor of 1/2. That means we're going to make them 1/2 as tall. Now the negative means we're going to reflect, so I'm going to put an arrow next to that negative. It means we're going to take those points and then we're going to reflect them over or in the x-axis. And finally, we're going to take those points, and the plus 1 means we're going to shift our points up 1 unit. So let's take our points first and graph our quadratic parent function. It may be a good idea for you to go ahead and memorize what those points are, or you can always make yourself a t-chart. It just goes a lot faster if you remember the points. Another way is without a t-chart is you can go to each one of your x values and square them, and that becomes the y, such as negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. And that just makes a real quick sketch of the points of the parent quadratic function. Now we're going to take these parent quadratic function points and we're going to shrink them by a factor of 1/2. So in green, I'm going to perform my first transformation. I'm going to take these points, such as 4, and shrink by a factor of 1/2. That means we cut it in half, so it becomes 2. 1 becomes 1/2. 0 and a half is still 0. 1 1/2. 4 becomes 2. So now we're looking at the green points, and we're going to reflect all those green points over the x-axis. Now to do that, you just need to find out how far away they are from the x-axis. This point right here is 2 away from the x-axis, so then it's going to go 2 down. So it's going to become negative 2. This point's 1/2 from the x-axis. It's 1/2 up on the y, so it becomes negative 1/2. 0 reflected over the x-axis is still 0. 1/2 is 1/2. And 2 again becomes negative 2. Another way to look at it is that all of your positive y values become negative, and then you just graph them on the other side of the x-axis. Now our final transformation is we're going to shift all these points up 1 unit, and then we can finally connect our dots to give us our graph. So we take negative 2 right here, we shift it up 1. 1/2 here, we shift it up 1. 0 shifted up 1. 1/2 shifted up 1. And negative 2 shifted up 1. And finally, we end up with the graph of y equals negative 1/2 x squared plus 1. Notice it's a little wider looking. It's been vertically compressed or vertically shrunk. It's been reflected over the x-axis, and then it's been shifted up 1 unit. Got one for you to try. Go ahead and graph y equals negative 2x squared plus 5, pausing the video, and press play when you're ready to see the answer. So again, you're always going to start with listing your transformations. Now, the negative 2 does things. The first thing the negative 2 does is it's going to vertically stretch our points by 2. The negative means that we're going to take our points and reflect them over the x-axis. Means we're going to take all of our positive y values and make them negative. And finally, the plus 5 means we're going to shift our points up 5 units. So first we're going to plot our quadratic parent function. 0 squared is 0, 1, negative 1 squared is 1, negative 2 squared is 4, 1 squared is 1, 2 squared is 4. Then we're going to stretch each one of these by 2. That means we're going to make them twice as tall, or make the y values twice as much. So instead of being negative 2, 4, it's going to be negative 2, 8, because 4 times 2 is 8. 1, notice the y value right here for this point is 1, so 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. And 4 times 2 is 8. So in the green, we've got our vertically stretched points. If that was the only transformation we had, we'd be done. But our next step says reflect over the x-axis. That pretty much just means you make all of the positive y values negative. So instead of being positive 8 right here, it's going to go down here and become negative 8. Instead of being positive 2, it becomes negative 2. 0, reflected over the x-axis, is still 0. 2 becomes negative 2. And 8 becomes negative 8. And our last transformation tells us we're going to shift these points up 5 units. So we're going to take negative 8, shift it up 5. 1, 2, 3, 4, 5. And we get our final point. Negative 2, 1, 2, 3, 4, 5. We get our final point. 0 shifted up 5 is 5. And I think you get the point. We're going to shift all of our points up 5 units. ending up with, in the end, our graph looking like this. Here's one last one for you to try on your own. Go ahead and press pause, press play when you're ready to see the answer. Quick note, when you multiply your y values by 2/3, you're going to get fractions. Now, when you're graphing fractions, just get as close to the value as you can. Now, I went ahead and wrote down the transformations: vertically shrink by a factor of 2/3, and then shift down 6 units. And I made an XY chart because in a moment I'm going to show you kind of from here what it means to shift, or rather shrink, by a factor of 2/3. We should already know it just means we make our y values 2/3 as tall, but what is 2/3 of 4? So essentially when we shrink by 2/3, we take all of our y values from our parent function and we multiply them by 2/3. If you remember, to multiply 4 by 2/3, you get 4 over 1 times 2 over 3, which gives you 8 over 3. Now when you're graphing points, it's almost necessary to turn those into mixed numbers. So 8 over 3 gives us 2, that would be 6 over 3, and 2/3. So instead of being 4, it's going to be 2, and 2/3 of the way up. 1 times 2/3 is pretty easy, it's just 2/3. 0 times 2/3 is still 0. 2/3, and again 2 and 2/3. Now that we've got all of our points vertically shrunk by a factor of 2/3, notice it looks a little bit lower. We're going to go ahead and take those points and shift them down 6 units. So instead of being right here, it's going to go down 1, 2, 3, 4, 5, 6. And there's our new home. So we go right here. 1, 2, 3, 4, 5, 6. 0 shifted down 6 is -6. And a great thing about quadratics is they're symmetric about the y-axis, meaning the other side should follow the same pattern as the left side. And you can verify that just by graphing the points again on your own. So I get, at last, a graph of my quadratic function y equals 2/3 x squared minus 6 by shrinking our points by 2/3 and then shifting them down 6 units.